Hi guys, today we're going to solve this problem in continuation for our lecture and solve problems for chemical engineering calculations in combustion analysis. No? So medyo mahaba itong ating calculation today because we will be answering 5 questions. No? But anyway, we're going to start now, so we'll not be taking much time in our introduction. Alright, so let us read our problem first. We have pure ethane, okay, as our fuel. So let us now take note of that. We have pure ethane here. So therefore we have here, okay, C2H6, which is 100%, okay, because we have pure ethane as our fuel. Now it is burned completely in 20% excess air. Okay, so we have air supply here having 20% excess, no? So we have 20% excess air here, and it is supplied at 25 degrees Celsius. So we have 25 degrees Celsius and 740 torr. And it is substantially dry, so we have dry air as our supply. Now we need to calculate first the Orsat analysis, okay, of the dry product of combustion. So we need to get the Orsat analysis, and then we need to get the kilogram dry air supplied. So kilogram air supplied over kilogram of fuel. And then for C, we need to get the cubic meters of air. So cubic meters of air per kilogram of ethane, which is our fuel. For D, we need to get the cubic meters of the product at 400 degrees Celsius. So we are given with our condition here, which is 400 degrees Celsius and 100 kilopascal. So we need to get the cubic meters of the product per kilogram of ethane, and then finally we need to get the partial pressure of water in the product of combustion. So we're going to solve all of this, okay, that is required for this problem. So let us now have our solution. Okay, so alright, so the first thing that we need to get is the Orsat analysis, but we know that we can only get the Orsat analysis if we get the number of moles of all our components here sa stock gas. Okay, so before we get that, we need to have the values of all our components here in our reactant, right? So let us start by having our basis. So let us have our basis in our fuel, which is, let's say, 1 kilogram mole of C2H6. Okay, so this is our basis. Right, so we know that we have complete combustion. Okay, it was written here. It is completely burned, okay, with 20% excess. So let us have our reaction first. So we have C2H6 plus oxygen, so because this is a combustion process, then this is a complete combustion, so we have CO2 plus water, right? So let us now write, let us first balance our equation, or our chemical reaction, I mean. So we have 2 carbon here, so we should have 2 carbons here as well in our product. So we have 6 hydrogen here in our reactant, so we need to have 6 hydrogen also here in our product. So we can have that by adding 3 in our coefficient for water, right? So now we need to balance our oxygen. So we have 2 oxygen here, and in here sa ating product we have 2 times 2, which is 4 plus 3, so we have 7 oxygen. So we will have here 7 over 2 in our oxygen. So 7 over 2 is also 3.5, right? So this is also 3.5. Okay, so our basis is 1 kilogram mole of C2H6. Let us check how much oxygen do we need in order to have complete combustion, because according to our problem we have a complete combustion. So that means we will be getting our theoretical O2, right? So our theoretical O2 is equal to 1 kilogram mole of C2H6 times 7 over 2 of O2, which is 3.5 kilogram mole of O2 for every 1 kilogram mole of C2H6. Okay, so this will be cancelled out. So therefore our theoretical O2 is 3.5 kilogram mole of O2. Okay, so that's our theoretical O2. Now we have 20% excess air, right? So we need to get how much is our excess air. So let us calculate for the excess air. So we have 3.5 kilogram mole of O2 as supplied, and 20% of that is our excess O2. So we have to multiply this by 0.2. So therefore let us use our calculator now. Let's see, we have 3.5 times 0.2, so we have 0.7. So we have 0.7 kilogram mole excess O2. Okay, so we already know how much excess O2 we supplied now. Now, how much oxygen we actually supplied here in our system? So that will be the theoretical O2 plus the excess O2. So our O2 supplied is equal to theoretical O2 plus excess O2, right? So our theoretical O2 is 3.5 kilogram mole, and our excess O2 is 0.7 kilogram mole. So therefore our O2 supplied is equal to, so we have 0.7 plus 3.5, so we have 4.2 moles of O2 are supplied. Okay, so now we have the amount of O2 that we supplied, but of course, since this is not supplied as O2 alone, this is air, so we know that there is nitrogen in our supplied gas. So we need to get how much is the N2 supplied. Okay, so how do we get the N2 supplied? So we have the number of moles of our O2 supplied, which is 4.2 moles of O2. Then we're going to multiply that to the mole ratio of our oxygen and nitrogen in air. So for every 21% of O2, we have 79% of N2. So how much N2 do we have, okay, in our supplied air? So we have 4.2 times 79 divided by 21. So we have 15.8 moles of N2 supplied. Okay, so as you can see, we got mostly everything that was supplied, no? But we need to get the number of moles of our product in order to get our Orsat analysis. So let me write again our reaction dito sa baba para mas madali nating ma-calculate. So we have C2H6 plus 7 over 2 O2 producing 2 CO2 plus 3 H2O, right? So we have 1 kilogram mole of C2H6. Then we have 3.5 kilogram mole of O2. Okay, this is the theoretical O2 for the complete combustion. And then we have CO2 here. So how much CO2 are formed in our product? So CO2 is equal to, for every 1 kilogram mole of C2H6. Okay, so since this is a complete combustion, so all of our carbon here will be burned to carbon dioxide. So for every 1 kilogram mole of C2H6, we have 2 kilogram mole of CO2. Okay, so that means for our CO2, we have 2 kilogram mole. Okay, so here we have 2 kilogram mole. Okay, so how much water is formed? Okay, so we have for every 1 kilogram mole of C2H6. Okay, so for complete combustion, for every 1 kilogram mole of C2H6, we will be producing 3 kilogram mole of water. Okay, so that means since this will be cancelled out, okay, so that means we will have 3 kilogram mole of water formed. Okay, so we have 3 kilogram mole of water formed because of this complete combustion, no? So let me have the cancel sign here para mas madali nating ma-visualize. Okay, so now we have the CO2 and H2O, but remember that we have excess O2, no, because we produce or we supplied extra oxygen here to ensure that we will have complete combustion. Okay, so that means we have free O2 or unused O2. Okay, so we have free O2. How much is our free O2? That will be our excess O2 here, which is 0.7 kilogram mole. Okay, so we have 0.7 kilogram mole. Okay, so now we can get our Orsat analysis, having all the details that we got. Okay, so let us have it here. First, our Orsat analysis. Okay, so based sa lahat ng na-calculate natin, what gases we will have in our stock gas. So we will have CO2. Okay, so let us write it here. We have CO2. Then we will have excess O2, di ba? Because not all of our oxygen will be used in the combustion. So we have O2. And then we will have nitrogen because we supplied air. So therefore, we expect that we will have nitrogen in our system. So we have N2. Now, we are looking for Orsat analysis, right? So that means we will not be considering the water that is in our stock gas. Okay, so that will be out of our calculation for Orsat analysis. So let us get the number of moles of every component in our stock gas. So we have CO2. How much CO2 do we have? 2 kilogram mole. Okay, so we have 2. How much free O2 do we have? 0.7. And how much N2 do we have? So we already calculated that. We have 15.8. Okay, so we have 15.8. Alright, so let us get the total of this. So we have 15.8 plus 2 plus 0.7. So we have 18.5. So we have total of 18.5. Now, since we are asked to get the Orsat analysis, we need to get the percentage of each component. So how much CO2 do we have? So we have 2 divided by 18.5 times 100. We have 10.81%. How much O2 do we have? We have 0.7 divided by 18.5 times 100. So we have 3.78. Okay, so 3.78%. And then finally, how much N2 do we have? So we have 15.8 divided by 18.5 times 100. So we have about 85.41. Okay, so 85.41%. So this is our Orsat analysis. Okay, so ano yung next na pinapahanap sa atin? The next one that we need to get is the kilogram of dry air supplied per kilogram of the dry fuel or the supplied fuel. Okay, so we'll get that here. So we need to get kilogram of dry air over the kilogram of our fuel, which is C2H6. Okay, so this is what we're going to find out here. Okay, so kilogram of, let me write this better now because it's so difficult to understand. So kilogram of dry air per kilogram of our fuel. Right, so how are we going to get the weight of our dry air? Okay, so how much is the number of moles of our dry air? So we need to get, we know that our air is composed of O2 and N2. So we need to add the number of moles of O2 and the number of moles of N2. So we have 4.2 K plus 15.8. Okay, so we have 4.2 plus 15.8. So this is the number of moles of our dry air. Okay, so number of moles of dry air. Okay, so this is what we have here, 4.2 plus 15.8. Okay, so we need to get the weight. Don't forget that we need to get the weight. So this is the number of moles. So we can only get the weight of the dry air by multiplying it to its molecular weight. So the molecular weight of air, as we know, is 29. So we have 29 kilogram of dry air per 1 kilogram mole of air. Okay, so now we have the kilogram of air in our numerator. Now the weight of our fuel. So we know that our fuel, which is C2H6, is our basis, which is 1 kilogram mole. So how much is the molecular weight of our fuel? So we have C2H6, right? So the molecular weight of C2H6 is, okay, let me go down, we're missing it. We have C2H6. The molecular weight of C2H6 is 12 times 2, which is 24, plus 6, which is 30 kilogram per kilogram mole. Okay, so that will be our molecular weight, 30. So let me remove that in order to have more space. So we have here 30 kilogram of C2H6 per 1 kilogram mole of C2H6. Okay, so this will be cancelled out, our kilogram mole, and also in here this will be cancelled out. So what will be left in our equation is kilogram air over kilogram of C2H6, which is our fuel. Okay, so let us calculate that using our calculator. Okay, so we have 4.2 plus 15.8. Okay, so this is 20 times 29, then divided by 30. Okay, so we have 19.33. Okay, so we have here 19.33 kilogram of air per kilogram of fuel. So this is our answer here in letter B. Okay, so now let us answer the third requirement. And here we need to get, ano nga uli yung question natin? Cubic meters of air over kilogram of ethane. So we need to get cubic meters of air per kilogram of ethane. Okay, so in order to do that, we need to get the volume of air. Okay, so we are talking about the air that was supplied. Okay, so the condition of our air supplied, let us recall it. In here we have 25 degrees Celsius and 740 torr. So our air supplied is having a pressure of 740 torr and a temperature of 25 degrees Celsius. Okay, so how are we going to get the volume of our air? So we can get that by comparing it to the air at STP. Okay, so we know that at STP our pressure is 760 torr. Our temperature is 0 degrees Celsius or 273.15 Kelvin, and our volume is 22.4 liter, and this is if our number of moles is 1 gram mole. Okay, alright, so we know in our ideal gas that we have PV is equal to nRT, right? Our R here is our universal gas constant, which is R is equal to PV over NT. Okay, so our R is constant at any given condition. So we could have our P1 over V1 over N1, and T1 is equal to P2 V2 N2 T2, right? Okay, so therefore to get our volume 2, we have V2 is equal to V1 multiplied to N2 over N1, then multiplied to P1 over P2, then multiplied to T2 over T1. Okay, alright, so now let us solve for the value of V2. Medyo move ko lang dito para mas malakihan natin yung sulat. Okay, V1, we know that our V1 is the volume of our gas at STP, so this is 22.4 liters, but we need to express that in cubic meter because ang requirement natin sa ating question is in cubic meter of air, no? So let us convert this to cubic meter. So we have 1000 liter for every 1 cubic meters. Okay, and then N2, which is the number of moles of our air supplied. So we know that this is the sum of the O2 supplied and the N2 supplied. So we already used that here, the moles of dry air supplied, 4.2 plus 15.8, which is 20, right? So we will be using that here. So we have 20 kilogram mole of air, and this one, okay, the volume of this is for every 1 gram mole of air. Okay, so we need to express this in kilogram mole. So we have 1000 gram mole for every 1 kilogram mole of air. Okay, so for our pressure 1 is the pressure at STP, and we have that here, which is 760 torr. So we have 760 torr over our given pressure, our condition of air, which is 740 torr. So 740 torr, then multiplied to T2, our temperature, okay, in our air, which is 25 degrees Celsius. So we have 25 plus 273 for it to become in Kelvin. Then our temperature at STP is 0 plus 273. Okay, So our units will be cancelled out. Our liter will be cancelled out. Kilogram mole will be cancelled out. Gram mole will be cancelled out. Torr will be cancelled out. And Kelvin will be cancelled out. Okay, so ang may iwan sa atin is in cubic meter. So what will be our volume here? Okay, so let us use our calculator. So we have 22.4. Okay, so by the way, our 1000 here will be cancelled out as well, so we don't need to include that in our calculation. So we have 22.4 times 20, and then times 760 divided by 740 times 273 plus 25, then divided by 273. So we have 502.24, right? So 502.24 cubic meters of dry air. Okay, so our requirement is to get the cubic meter of air per kilogram. Okay, so cubic meter of dry air per kilogram of our fuel, which is C2H6. So we have 502, sorry, let me write that again. So we have 502.24 cubic meters per weight of our C2H6. So we have 1 kilogram mole of C2H6, which is 30 kilogram of C2H6. Okay, so therefore we have here 502.24 divided by 30. So we have 16.74. So 16.74 cubic meter of air per kilogram of C2H6. So this is our answer for our third requirement, right? So now we need to answer the third one. So our question, fourth one, I mean. So the fourth one, we need to get the cubic meter of the products of combustion measured at 400 degrees Celsius and 1000 kilopascal per kilogram of ethane. Okay, so we will be checking now on our stock gas. Okay, so our port, which is D, we need to get the cubic meters of our stock gas per kilogram mole of C2H6. Okay, so parang katulad din ng ginawa natin kanina, no? We need to get the volume, okay, of our stock gas, okay, because we need to get the cubic meter of the stock gas. So we will be using the same equation that we used here. Okay, so since nakuha na natin siya, we just need to use it and substitute our new value. So we have V2. Okay, so we have V2 is equal to V1 times, okay, let's say what? N2 over N1 times P1 over P2 over T2 over T1. Okay, so what is our condition now? So we know already our condition at STP, no? So we need to get now the condition at stock gas. So given naman to sa atin, what's the pressure and what's the temperature. So our pressure here is let's just recall 400 degrees Celsius temperature and 100 kilopascal pressure, no? So we have here 100 kilopascal and 400 degree Celsius. And what is our number of moles here in our stock gas? So ito yon, alam na natin, meron tayong in our Orsat, we have 18.5 excluding water, no? So we're just going to add water there. So we have 18.5 plus the number of moles of water, which is 3, I think. So let me recall. Yes, water is 3. So we just need to add that here. So 3. So that means our N is equal to 21.5. So 21.5 kilogram mole in our stock gas. Okay, so alam na natin yan. We just need to substitute those values here. So we have our V2, yan ang hinahanap natin, times V1. Our V1, which is the volume at STP, 22.4 liters. So it should be in cubic meter. So we have 1,000 liter per 1 cubic meters. Alright, so now our N2, which is 21.5 kilogram mole, and our N1, which is 1 gram mole. So we need to convert that to kilogram mole. So 1,000 kilogram mole, 1,000 gram mole, I mean. So this will be 1,000 gram mole for every 1 kilogram mole. And then for our P1, which is the pressure at STP, so we have 101.325 kilopascal. And our P2, which is this one, 100 kilopascal. Then for our T2 is 400 plus 273. So hindi na natin susulat dahil maubusan tayo ng space, no? So we have 273 plus 400, so we have 673 Kelvin. And for our T1, which is 0 degrees Celsius, so we have 273 Kelvin. So let us check our units. Liters will be cancelled out, gram mole will be cancelled out, kilogram mole will be cancelled out, 1000 will be cancelled out, kilopascal will be cancelled out, and Kelvin will be cancelled out. So our unit will be in cubic meters, no? So let us now solve for our V2. So let us use again our calculator. So we have 22.4 times 21.5, right? Then let us multiply that to 101.325 divided by 100 times 673 and divided by 273. So we have 1202.97 cubic meters of stock gas. Okay, so our requirement is cubic meter of stock gas per kilogram of our fuel. So we have cubic meters, we have cubic meters of stock gas per kilogram of C2H6. Okay, so cubic meter of stock gas, which is 1202.97 cubic meters, divided by the weight of our C2H6, which is 30 kilogram of C2H6. We already know that, so we just need to calculate this now. Okay, so 1202.97 divided by 30, so we have 40.09, or let's say 40.1. So we have 40.1 cubic meter of stock gas per kilogram of C2H6. So this is our final answer here. Okay, so finally, our last question. Okay, so isa na lang. Let's have it here. So ang hinahanap natin dito is, I think, partial pressure of water in the product. Okay, so we need to get the partial pressure of water at stock gas. Okay, so we need to take note of what we have learned sa ating physical chemistry class, that the partial pressure of our water over the total pressure is equal to the number of moles of water over the number of moles total. Okay, so the pressure fraction is equal to the mole fraction. So we need to get the partial pressure of water, right? So that means we have total pressure times number of moles of water over the number of moles total. Okay, so what's the partial pressure of water? Having that, our pressure total in our product, in our stock gas, we have it here, which is 100 kilopascal, diba? So we have 100 kilopascal times the number of moles of water. We have seen that already, which is 3, right? So number of moles of water, sana yon? Calculate natin kanina. Here, the number of moles of water is 3. Okay, so we will be using that sa baba. So we have 3 kilogram moles of water. Now the total number of moles in our stock gas, and we use that already down here, no? Where is it? Here we have here 21.5 kilogram mole, because this is the from our Orsat analysis, the number of moles of our components plus the number of moles of water. So we have 21.5 kilogram mole total. Okay, all right, so now we can cancel this out, kilogram moles and kilogram moles. Now we will be left by the unit kilopascal. So our partial pressure of water is therefore equal to 100 times 3 divided by 21.5. So we have 13.953. So 13.953 kilopascal. And this is our final answer here. Right? So we are able to solve all of the questions, no, dito sa ating problem. And as I said, mahaba siya kasi ang daming question na sinagutan natin. But anyway, I hope you find this video useful sa mga nag-aaral ng combustion. So whether you are taking chemical engineering or mechanical engineering, so I hope you find this useful. Okay, so we will try to solve more problems in the future. So with all of that and more, I will see you in our next video. To watch more of our lecture videos about engineering and STEM subjects, please subscribe to our YouTube channel and click on the notification bell para lagi kayong updated sa mga videos na i-upload namin. We are regularly uploading tutorial videos in engineering, mathematics, chemistry, physics, at iba pang subject na magagamit ninyo sa inyong pagre-review. So, thank you very much sa patuloy ninyong pagsuporta sa enginerds.org.